Welcome to 7.3 Day 2, Rational Exponents. So today we're going to evaluate expressions of the form b raised to the m over n power, and we're going to solve exponential equations. So for any positive real number b and any integers m and n greater than 1, b raised to the m over n power is the same as, in parentheses, the nth root of b all raised to the mth power. So you'll notice when we do this, the other day we did 1 over n, and then n is what went with the radical symbol. Well, now we're going to put another number in the numerator of our rational exponent, and that's going to go on the outside. So an example below is 8 to the 2/3 power is the same as the cubed root of 8 squared, which is the cubed root of 8 is 2, so we have 2 squared, which is 4. And this is what we're going to do with rational exponents today, is we're going to break them down, rewrite them in a different form, and then simplify them. So here we have 64 to the 2/3 power. So what we are going to do is rewrite this like was shown on the previous slide. So 64 to the 2/3 is the same as the cubed root of 64 squared. If we take this, if we take the cubed root of 64, we get 4. That's our parentheses now. We simplify the parentheses. We have 4 squared, which is 16. And yes, I do want to see you guys breaking these down, putting them in a different form. So we have 36 raised to the 3/2 power. This is the same thing as the square root of 36 cubed. Remember, the denominator of the rational exponent is what goes with the radical, and then outside the parentheses is what the numerator goes there. The square root of 36 is 6, and then 6 cubed. We do that, we get 216. The next we have 27 raised to the 2/3 power. Again, that denominator is what goes with the radical, so we're looking at the cubed root of 27, and this is all squared, which is our numerator of our rational exponent, and we get 3 squared, which is 9. And lastly, we have 256 to the 5/4. So we are going to have the 4th root of 256 all raised to the 5th power. And if you take the 4th root of 256, you get 4. Then we have 4 to the 5th power, which is 1024. So I do want to see this progression where you change the rational exponent into a radical form. So I want to see that part, and I want to see these steps. So you get the radical form, you simplify what's in the parentheses, and then take that to whatever power there is and get your final answer. One thing that's nice with this is you can verify you do it right by typing in that 64 to the 2/3 in your calculator, and you should get that same answer back that you find after you break it down and go through the steps. Exponential equations. In exponential equations, variables occur as exponents. We can use the power property of equality and properties of exponents to solve these exponential equations. For any real number b greater than 0, so we have to have a positive base, and b not equal to 1, because if b was 1, anything 1 raised to any power is still 1, then b to the x equals b to the y if and only if x is y, which makes sense. If we have the same base raised to an exponent x and the same base raised to an exponent y, well, the x and the y must be the same number. So like it says here, to do this you must have the same base. So if 5x equals 5 to the 3rd, what we can do is just take the exponents and set them equal to each other because we have the same base. So we set the x equal to 3. As we have the same base, then x equals 3. And it shows here we can go sort of in the opposite direction. If we know that n is 1/2, then 4 to the nth power equals 4 to the 1/2 power. We're going to use this to solve what we call exponential equations. So when we have these, you look at number 1. The first thing we need to do is have the same base. So we need to figure out what number we need to get the base of 6. So 6 multiplied by itself, how many times equals 216. That's our first thing we need to figure out. We know we have to have 6. So how many times does 6 multiply together? And you can do this on your calculator, 6 times 6, and do it until you get to 216. And this is 6 to the x equals 6 to the third. That means that x equals 3, because we take those exponents and set them equal to each other. Next, we have 5 to the x power equals 125. Again, we need to have that same base, so we know we have to find 5 multiplied by itself how many times. And we get 5x equals 5 to the third. And again, we get x is 3. Next, we have 25 raised to the x minus 1 equals 5. Well, this time we have to take what's on the left side and get the same base. This one gets a little more tricky. So we have 5 raised to the second power is 25. And then we have our exponent we had before, x minus 1, in parentheses now, equals 5 to the first power. And this time we want to put that first power there. So we have to take what's in our exponents and set them equal to each other. So we have 2 times x minus 1 equal to 1. And now we're going to solve this equation. So we have 2x minus 2 equals 1. And we add 2 to both sides, you get 2x equals 3. We divide by 2, and we get x is 3 halves. This one we have to do a little more work, because we have to find that same base. Then when we do that, we get 5 squared. And we have to take that 2 and multiply it by the original exponent of x minus 1. The last one we have is 12 raised to the 2x plus 3 equals 144. So 144, we want to have that same base, and we're going to have 12 raised to the 2x plus 3 equals 12 squared. And now we take our exponents and set them equal to each other, now that we have the same base. So we have 2x plus 3 equals 2. We subtract 3. We get 2x equals negative 1. We divide by 2, and we get x is negative 1 half. So this is solving exponential equations. The first thing we need to do is make sure we have the same base. And if we have the same base and we have the equal sign between them, we can set the exponents equal to each other and solve for the variable like we've done before. So here, I want you guys to try this. The first one is what we did on the first slide, basically. We want to rewrite this as a radical and then simplify. And then number 2, we're going to do with we want to get the same base and then set up the exponential equation and solve it. So please pause your video and try both of these. So with number 1, the first thing we want to do is simplify the parentheses. So we have 8 squared, which is 64. Now we have 64 raised to the 2/3 power. This is one of the approaches. You could have brought the 2/3 power in and then had 8 raised to the 4/3. It's up to you. We have 64 raised to the 2/3, and then this becomes the cubed root of 64 squared. And this becomes 4 squared, which is 16. For the bottom one, this one's a little tricky also. We have 25 raised to the x. And this is 125 in the denominator, but we could move it to the numerator and get 125 raised to the negative first power. Then we want to get the same base. So we have 25 to the x and 125 to the negative first. Well, there's nothing, 25 multiplied by itself is going to get to 625. So we need to get the base a little lower. So we're going to look at what multiplied by itself gets to 25, and we have 5. But then we have squared, and then we all have this x power still, so 5 to the 2x. This is going to be 5 to the third, and we also have that negative 1 up here. So now we have 5 to the 2x equals 5 to the negative third. We're going to set up our equation for our exponents. So 2x equals negative 3, and we're going to divide by 2. And we get x equals negative 3 halves. All right, so this is what you'll be doing today in your homework. We'll be taking these rational exponents, we'll be rewriting it to where we have a radical, and then we'll simplify from there, like number 1. And then number 2, we have exponential equations, where we have to get the same base, and then we're going to set the exponents equal to each other. So that is all for 7.3 day 2. Thank you for watching, and have a nice day.